Hello, I'm Graham Wakefield. I'm a professor in York University in Toronto in Canada and also co-founder of the Artificial Nature Project with Dr. Harajee. First of all, thank you for the invitation to speak here at Chung'an University International Metaverse Festival. I'd like to take this opportunity to talk about computational world making by reflecting on the last 2 decades of my work, both in building computational worlds as a software developer and as an artist. And this is built on a background in philosophy and music and AI and a few other things. And I'm going to try and contextualize all of that with some pictures of where I'm coming from and some thoughts on where we may be headed. So my VR XR journey began 20 years ago. And I spent most of my PhD in the Alisphere, this research center at the University of California, Santa Barbara. It's a spherical theater-like pavilion of opaque material suspended within a 3-story near anechoic cube located in the California Nanosystems Institute. A metal sphere with a bridge through the middle surrounded by 26 stereoscopic projectors and 56 loudspeakers. It's a virtual reality instrument conceived for both scientific visualization and for art. Now, I came here with a focus on electronic music and a background in web design and math and philosophy, but Professor Joanne Kacharan-Morin, the director of the Alisphere, she said we should consider the Alisphere as an instrument both in the musical and scientific senses, and that really deeply resonated with me. But the question was how to make this real, how to build this, how to build worlds for this space. And even just getting pixels on the screen was quite a technical feat. I worked developing code to render OpenGL applications over all of these projectors and computers with stereoscopic projection and spatial coherence and proper colors and blending and so on. It was quite a lot of work just to do this. Doing the warping for a VR headset is much easier, but it worked. Here's the final thing. And here's a little snapshot of one of the first projects that was shown in the Alisphere. Now, this project originated from the idea of an architect wanting to explore his brain as an architecture. It was designed to be indicative, communicating the potential of the space and a helpful marker of where to go. And it also served as a prototype, driving the infrastructure and working methods in the Alisphere. But the goal of visualizing science didn't always reach its full potential. So here, for example, is an amazing experience visualizing nanomedicine drug delivery within the human vascular system. But it's still somewhat like an immersive diagram, a fantastic journey as a promotional tool. The problem is it's not by itself research. It's an image of research. And it's also not exactly an art of world making either. There was a problem of getting to the collaboration too late in the stage of the research, for example. Once you know that you can fill an XR space, how do you create? So the daily experience of working in a space like this looked like this. It looked like a lot of looking at laptop with Linux terminals spread randomly all over the surface. It's painful to edit any application, to stop, edit, debug, and redeploy when the world is spread all around you. Live editing, and ideally collaborative editing, is another musical influence that has come back to us again and again and again. And it's another one of the reasons why we ended up building our own software structure. So then the question is, how do you construct a world to be able to work with systems and simulations and not the pictures of the results? So we started making tools, an integrated collection of components to assist the tightly integrated construction of immersive, navigable, audiovisual worlds. We built these ourselves. Over time, it became a toolkit of world-making components that grew to incorporate computer vision, mixed reality, stereoscopics, ambisonic spatial audio, depth sensing, navigation, and many more. It also included techniques for what we thought of as spatializing computation, spatializing processes such as dynamic fields, interacting intelligent agents, attaching data flows to points and fields of a world. This is beginning of a notion of computational world making. And some of these tools were used outside of the origin in the allosphere in courses and exhibitions all over the world. Some also made their way into commercial products. Here's a spatializer for WorldViz that was recently updated for Jeremy Bailenson VR lab at Stanford, for example. My doctoral research dug into this question more deeply, focusing on the core problem in software design for creative tasks as a tension between optimization and open-endedness. We know that we can optimize code by prior specializing that code, where you can infer better solutions by knowing the problem in advance. In a game engine, you would bake elements, pre-bake lighting in order to maximize performance and so on. But of course, this comes at the cost of freedom in the game. There are fewer options of action. There are invisible walls that stop you. Or if you thought about it in terms of reinforcement learning, it's kind of the trade-off between exploitation versus exploration. For a creativity support tool, for generative arts, this kind of pre-limited sets of execution paths are really unpleasant for a creative flow. They're incompatible with the idea of live improvisation. So how do we find our way around this balance between optimization and open-endedness? In my doctoral research, I focused on this using audio synthesis as a prime example and addressed it by using reflective programming and dynamic just-in-time compilation, which simply means that optimizing only the latest idea expressed by the user and keeping it only until they have a new idea. It led to a tool called Gen that has become quite widely used in the last 10 years, and I believe it's become popular because of this freedom from pre-optimization allows people to express ideas at a much finer and freer level of granularity. It now has tens of thousands of users, including a number of famous artists, large research groups, as well as many communities, university courses, and so on. In fact, it's been popular enough that we were able to write a textbook, and that textbook has also been a big hit. I think a lot of the popularity comes down to how working with compiling on the fly means that we can work at the lowest level without any loss of efficiency, without any restrictions. And this makes it easier to open and demystify the immense possibilities of algorithms for signal processing. So things that used to be obscure in software or laden with mathematical expectations in literature turn out to be a lot simpler in practice and also a lot of fun. This is also influenced by this field of live coding, pushing the plasticity of computing into more hands. So live coding is a performance practice that emerged in electronic music, where performers code the music live, often projecting the code as they're making it. And so the problem here isn't defined in advance. The goal is to play and discover beauty in dialogue with a micro-world of computational sound or other media. And as you can see, music has this tradition of being a collective, collaborative experience. So of course, we tried bringing this kind of live coding into an immersive world, like here in the Allosphere in 2013, and it worked. But staring at your laptop really isn't the best way to be immersed in a world. So one of the research projects that I've been running in my current lab followed on from this, and it is directly inspired by this quotation from VR pioneer Jaron Lanier, his vision of VR as a collaboratively improvised reality. And of course, this is also taken from a musical performative context. So for example, here, Mishmash is a prototype inspired by electronic music and modular synthesis for what it means to live code a world around you. Here the graphs are creating sound, but they could just be creating any aspect of the world. And the hypothesis is that at least part of what makes this kind of synthesis fascinating may also illuminate ways to further inform and develop what VR and XR are themselves. So in this case, it's also a multi-user environment. So we have this collaboratively improvised sonic reality, at least. Each user edit is shared to all clients and dynamically modifies the synthesis code, which is being recompiled to machine code for a seamless, open-ended sonic experience. And it also opens questions of like, what if we could fork worlds in place? What if we could have parallel versioning and then merge worlds together, or stepping into submodules as rooms within worlds, for example? Well, it's an audio-focused project, but the idea is to extend this immersive collaborative patch programming into visual and also simulation content. And then later I found out that this idea wasn't new, of course. It was VPL back in the 80s had a live node-based programming environment for developing VR applications using a language called Body Electric, which blended high-level incremental compiler with data flow. And in fact, in Lanier's book, he also talks about MaximSP and also the Allosphere. So there's seems like we're on the right page, at least. As Lanier says, making VR while sat at a desktop is like trying to learn a foreign language from a book, and that just feels wrong. So, very briefly, computational world making is a way to rethink this whole process. A new medium like XR is a new chance to rethink how we do things, not just to import old methods, to get beyond the questions of how do we make XR to the real questions of what makes a world, and what would computational world making become. So in response to this question, I've always thought of experiences rich in immersive, sonic, visual, and other modalities, environments that we could, to a certain extent, co-inhabit, populated by other beings with which we can interact and play. And it's also a way of thinking about how we can make every part of the space around us imbued and alive through computation. And it was in this basis that we began the Artificial Nature project in 2007. I'd like to reflect on this a little bit, and I'm going to show some background to the Artificial Nature project and then a couple of the works. But mainly, I'm thinking here, what is a metaverse without other species? Most examples of the metaverse that I see are essentially human-machine interactions, but isn't one of the most interesting things that we could do with the world to meet other beings? Anyway, Artificial Nature begins from this. We look to nature for inspiration, creating interactive art installations surrounding humans with biologically inspired complex systems experienced in immersive mixed reality. Through building immersive artificial ecologies, we're questioning how we may coexist with non-human beings in ways that are more abundantly curious, playful, and mutually rewarding. So we start from this idea, as I said, of the computer as a second-order machine. What does that mean? A second-order machine means a machine that can become another. Here's Christopher Langton describing programming computers as extremely general behavior generators. They don't really have an intrinsic behavior of their own. We provide that behavior with programs. And if we know the formal description of one machine, then we can make the computer become that machine. That means that computers can become artificial universes for exploration. Well, we can use dynamic code generation to achieve this, for example. Here we, using the same essential method of generating code and compiling it on the fly, but in this case we can generate the code in an evolutionary manner, in a complex space, such that the species can explore the space of the full space of possibility, computational possibility, and create a much deeper, more open-ended environment. Here's an example of this working not in a visual realm, but in a purely sonic realm. Here there are a number of loudspeakers, each loudspeaker having its own generated code for input and output. They're essentially talking to each other, responding to each other, and modifying their code as a result in an evolutionary way.
Moves at random until it is free of the obstacle.
And this is an opportunity to also point to the thin boundary that exists between the living systems and computational systems. And in this way, begin to conceive of life differently from the life that we know. Biology traditionally worked top-down, dissecting organisms down to molecules. But as we got down to the molecular level, they begin to look more and more like machines, or at least more and more like the non-living materials. In fact, it seems like life differs from non-living things mostly in terms of its organization and emergent self-organization. So the question came up, could the same organization happen in other media, including computation? This is the beginning of the field of artificial life. And it turns out that the complex emergent behavior can emerge from very simple structures and behaviors, and in that way we can investigate life from the bottom up, not limited to life as we know it, towards life as it could be. So we've always looked to computation as not intrinsically utilitarian, nor in opposition to nature. We see it instead as a material means to plunge even more deeply into what nature is and find our place within it. So this led to the birth of this artificial nature collaboration, and here's one of the first works that we created in the Allosphere, an entirely surrounding world of artificial fluid simulations and multiple species interacting with each other. And I'll be sharing a few more works with you. This is called Fluid Space and led to a piece called Endless Current. As soon as the earliest head-mount displays began to become available. So here, this was in 10 years ago, we developed a piece for the Oculus Rift as it first came out, and experimenting with ways to try and bring the body back into this immersive space. We are deeply inspired by the organizations and structures of nature beyond and below the human scale. The artificial life forms here are subsisting within a simulated 3D fluid environment that is constrained by an amorphous landscape reminiscent of an underwater or microscopic space. We're committed to immersion in complex dynamic processes, inspired by nature's example and yet different to it, as something that we've never been able to experience before. It means making worlds with depths of discoverable kinds, where every perceivable form has multiple real relationships and functions with other parts of the system, and nothing is static, nothing pre-baked, and no surface effects. That means everything has a dynamic ontological role with everything else, including you. So just as we see the wind by how it moves the leaves, here we see the fluid by how it moves the particles. The world is explorable infinitely. Its architecture is constantly evolving, shaping and being eroded by the fluid currents. And just as the autumn leaf's shape and colour describe its decay, particles crumple and desaturate as their energy is lost. It's possible to watch organisms gradually mature from eggs into fully developed creatures and consume nutrients. The particles are not visual effects as you might find in a video game. Here you can follow one particle changing colour and form as it gains or loses structural energy, as it passes through the fluid space, through the metabolisms of one or another species. And up close it's also possible to observe them inside, being digested as they're eaten, and then ultimately ejected back into the environment. And in here, every element is related to every other in a complex network. But VR has this limitation of the body, of there's a certain weakness of interaction that we wanted to explore more deeply. And here we were inspired by Summer Réunion and their description of the role of visitors as a visitor must become part of the system to realize that there are no predefined solutions of what to do and what to see. This is not pre-optimized. And that instead the artwork develops through his or her interaction. The longer one interacts, the more one becomes part of the system. This is obviously a very cybernetic perspective on interaction and embodiment, in which there is a complex, continuous feedback of input and output between the viewer and the artwork, to the point where we get to the artwork embedded within an environment within the artwork, and the participant embedded within an environment within world, and both of those becoming embedded within each other as a form of shared reality. For us, working with shared realities means the coexistence of possible worlds and the physical world. When we started, we thought of artificial nature as an artificial life art form, but it became apparent that we're not building life forms, but we're building ecologies, and humans are part of that ecology. Our stance is to maintain a flat ontology, which means that we're not making one world less important or to the other. Instead, we borrow ideas from how nature works, where there are no strict hierarchies, where there's an exception to every rule, and there's a pathway in almost every aspect that has been explored by life. We're excited by the potential of mixed reality as a way to resolve how we can bind virtual spaces to physical places in functional as well as contextual ways. For example, we'd seen many exhibits around this time of using VR headsets, but what you saw in the VR headset could have been viewed anywhere. It doesn't matter where you were. Wherever it was, it can present being somewhere else that had nothing related to your location. So then the question came up, what ties a work to a place of an exhibition in particular? How can it avoid an inherent sense of disconnection? So rather than virtuality presenting an escapism to independent worlds, we think it could connect deeply to a particular place, ontologically rooted in something site-specific, perhaps revealing expansive possibilities within what is physically present, not only in being there, but being there. So here's Conservation of Shadows. This was a piece in which we explored this idea, and it was installed at the Sema Chango, a recently acquired expansion of the Seoul Museum of Art, within the former grounds of the Korea Center for Disease Control. As a historical building, it has a great balance between order and disorder. Sunshine changes the tones of the space. We began to imagine new beings growing fond of the wet texture of old wood, the fragrance of the sunshine smeared between cracks, the quietness of murmuring and whispering. And to let them live, we extended the senses to mixed realities surrounding people with softly ringing bells and the crunch of salt underfoot. The heart of this piece is the physicality of shadows as a liminal bridge suspended between superposed physical and virtual space in both mathematical and also mythological senses. We all have our shadows, and we share them with other beings. The floor of the room, covered in salt, is felt as you walk over it, and each crunch leaves its mark. Softly ringing bells surround the space, ringing with various intensity as you see the shadows of the creatures pass by. And those who enter VR have not left this place. They have not lost their bodies nor their shadows. By donning a head-mounted display, visitors take on an alternate perspective to witness a world coexisting in superposition with us. What first appeared as flat shadows on the floor are now unveiled to be creatures moving around and through our now shadowy bodies and responding to our movements and gestures. Later this work was invited to exhibit at the Biomedia exhibition at the ZKM in Germany, which opened in 2021. Here we responded to the specific history of the building, including being a factory for ammunition during World War II, and also stories about a basement that has remained closed ever since. Here we focused on a system of interconnections between memory and imagination, visualized as point-like thread traces of beings and behaviors, the visual structures being woven by the spatio-temporal occupation of other creatures. The primary behaviors of the creatures here were driven by curiosity. We use curiosity not only as an effective means of discovery, but also because curiosity is the beginning of empathy, how I and you become we, and how we may envision worlds that could be. Last year it was also shown at SIGGRAPH in LA, the major industry and academic event in computer graphics. Here's some footage from this event. We've witnessed a lot of participants playfully experience conservation of shadows throughout and become part of the whole system. And in particular, it's interesting to see how people can interact with each other within and outside of VR, and even with other species. We saw how people felt comfortable to sit down or lie down on the floor while observing the world. And we met so many people at the conference exhibit, as well as the artists and other events, and one question that remained in our thoughts, one question that we were asked is, why don't you make how the brain actually works? But what does that really mean? In the real world, you can notice other creatures through their shadows. In the virtual world, you have now become a shadow, a volume shadow, of interest to the creatures. We visualize point-like and thread-like traces of beings and behaviors into building memories as interconnected processes of visual structures. The creature's movements are based on a prediction and surprise process, which is at the core of models of curiosity. The creatures predict where we might be in the next moment and face in that direction. So if you stay still, they'll writhe around inside you and their trails make a memory of you in space. But the more that they are surprised by your movements, the faster they move to follow, aiming for the source of the surprise. It makes it feel like they are following us, especially following any kind of unexpected movements. And if their prediction keeps on being good, if we just stay still in one place for a while, their curiosity reward becomes lower. They get bored and drift up to the sky for a while until their thirst for new input brings them back. Quite a few visitors decided to lie down on the rug and stare into the sky for a while, and this is what they see. The smaller creatures follow the short-term memory trails left by the larger creatures, and as they go, these smaller creatures spin out threads as longer-term spatialized memories. These memories are not static, but active in continuous motion. Sometimes the threads make loops that stay in place, like a strongly retained memory, but the loop will drift and slowly change shape. It's a bit like how, in our minds, each time we recall a memory, our memory is changed slightly. Sometimes a thread will split into two or more similar threads, and when threads get close to each other, they can get mixed up and connect with each other, a little bit like an imaginative association or mental slippage. So, when people asked, why don't you make how the brain actually works, we reflected, in fact, in some ways we already have been and we continue to. And part of this comes from this interest in curiosity and creativity. Curiosity means a continuous learning like children and non-human organisms do, playfully, socially, creatively, and without any external reward or punishment. This means it is intrinsically motivated, not predefined to a fixed task. And we've begun to see how that's vital for artificial intelligence too, as it is how we can adapt to an unforeseen future. It's also how we make sure that we don't bottleneck our future with ideas fixed in the past, like biases frozen to pre-trained AIs. So can we learn about curiosity and creativity from other species? Our explorations of complex networks of non-human intelligence continued in our next work, Entanglement. Inspired by the motif of the forest, the idea was to draw attention to the invisible, symbiotic living information network beneath our feet, in the fungus thriving beneath the trees. All three of the systems that you see here, trails, networks, and fungus, explore their environment by sensing difference, the first step of learning and curiosity. And we thought, what is it like to be a fungus, a massive distributed being, communicating between the trees that it can never see? Does it dream of what trees might be? This is asked as an opportunity for contemplation and inspiration regarding ways of connecting the world beyond ourselves, as well as emergence, creativity, and also a different idea of emerging computational intelligence. So we started to look at the way that AIs can dream, as a wandering stream of images. The idea here was for the dreams to form the above ground of the fungus. We encountered many challenges. Generative AI, stable diffusion, and control net. Each image is fed through a process and fed back into the AI again. The problem is we were constantly battling with an AI that's trying to please you. trying to add in non-diegetic details like frames and labels, or producing low levels of consistency, fractal patterns, and very often becomes too bright or too dark or too high contrast. So we continue to explore by driving these with models, procedural models of geometries that we produced ourselves. And here we're beginning to use generative AI as part of the work of the pipeline, not as an alternative to our artist who creates the entire work, but just one more brush within our system. So we've been exploring how we can generate imagery beyond conventional uses, such as non-human subjects generating very wide images, long sequences of images to show the growth and changes of a forest. And this has also revealed some interesting other limitations to work around. Here's a snapshot of our result, combining procedurally grown trees with dynamic fungal networks and their dreams of what their above ground world looks like. And here's the final work, created as a site-specific non-real-time feedback system for the XR Lab at Ulsan Art Museum. Inspired by the motif of the forest, it invites spectators into a multi-sensory, multi-dimensional, immersive environment where visible and invisible worlds are interconnected and symbiotic. The artwork consists of 3 elements: the growth of trees through procedural modeling, generative AI that dreams images of trees and forests, and the operation of dynamic systems that connect tree roots with the mechanisms of fungi and bacteria, or of neural networks within the brain. The artwork offers sensory opportunity for contemplation and inspiration regarding ways of connecting with the world beyond ourselves, as well as emergence, creativity, and computational media technologies. Of course, what we really wanted to do was bring humans into this wonderful underworld as another part of the system. So here's some images and videos from We Are Entanglement, a subsequent work that was shown at the Vancouver International Film Festival, using a smaller segment of the world on a large LED wall and using LiDAR sensors for interaction. It was lovely to see here how instinctively people wanted to form new entanglements, both with the trees and fungus and also with each other. So generative AI, artificial intelligence in general, has given us homework that requires overcoming our own criticisms. Artificial ecosystems and non-human perspectives, entanglement in and between decentralized networks, and artificial curiosity, we think, provide an aesthetic experience of an unknown forest that may expand our world. This can be the first time in human history that we can create artificial worlds which can question, examine, and search for their own goals within, along with their human participants. We are hoping that through this we might build a future that's not just resilient but is anti-fragile. Systems in awareness that our environments and real-world problems are always complex and dynamic. In order to achieve that, we know that we must avoid static measures such as predefined fitness functions or objective functions. We always want the world where we can become a better us in the future, and for us that means striving to make our future world a deep and healthy forest that embraces both order and disorder without losing its wild nature. Thank you.